Hi guys. All right, so we are starting. Let me get rid of all this old stuff. All right, we are getting started with dividing fractions. And so we're starting off with dividing a whole number by a fraction. So that may look something like 5 divided by 1/4. So what we're doing is we're starting with a whole. So I've got 5. So I'm going to think of 5 wholes. So here's 1, 2, 3, 4, 5. And the 1/4 is telling me how many that I'm going to have in each group. So I'm going to look at this denominator 4, and that tells me that each of my wholes is going to be broken into 4 parts. So 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Oops. All right, sorry, I'm drawing with my finger. All right, so each of those is broken into 4 parts. And so my answer, if I am starting with a whole number, I'm going to end with a whole number. And so what I'm doing is just counting how many parts I've made. So if each of these is broken into fourths, I've got a total, if I counted that up, there's 4 here. This would be 8, 12, 16, and 20 total parts. So that would be 20. The algorithm, how it looks when you, without the model, would be just 5 divided by 1/4. And we teach the kids KFC, which stands for keep for the K, and then flip for the F, and C for the change. And so we're going to keep the 5, but we're going to write it as a fraction. So this is going to look like 5/1. And then we're going to flip the 1/4. So we're going to find the reciprocal. So we're going to just flip it to where the 4 is at the numerator spot and the 1 is in the denominator spot. And then we're going to change the division symbol to multiplication. And then we multiply straight across. 5 times 4 is 20, and 1 times 1 is 1. And anytime we have a number over 1, that's the same thing as just that number, so 20. So here's that 20 that we got originally. So keep, flip, change. All right, let's try another one. This time we are going, instead of doing a whole number by a fraction, this time we're going to be dividing a fraction by a whole number. So this time we're starting with a fraction, and all of our fractions that when we're dividing in fifth grade, they're all going to be unit fractions. And so they're all going to have that 1 in the numerator spot. This time we're going to be dividing that, let's say, by 3. And so this time we're starting with a fraction. So I need to show that. So here is a fraction, and I need it to, I'm going to look at that denominator 4, and this is going to be cut into 4 equal parts. And so I'm going to highlight 1/4 of that. So here's me starting off with 1/4. Then what I'm doing is I'm going to take that 1/4, and when you see this division symbol, I'm going to cut it or split it into 3 equal parts. And so I'm going to show that with my red line. So I'm just going to cut this into 3 equal parts. And then now I'm going to think about my answer, is going to be um, this part right here, and this is what each group receives out of the whole. So once you split it into the three groups, so you're starting with 1/4, you split it into three groups because we're dividing by 3, and then this is what each group receives out of that original whole. So this, now I've got, if you look at it, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 parts. And I'm talking, my circled part is just one of those 12. And so that's with the model. And then here's what it looks like with the algorithm. So let's say we've got our 1/4 divided by 3. We're going to rewrite this. Remember, K, F, C. We're going to keep the first fraction. Then we're going to change the second one. And this is the same as 3/1. So when I change it, when I flip it, I'm going to be finding the reciprocal. And so that would make it 1/3. And then I'm going to change the division symbol to multiplication. And I'm going to multiply across. So 1 times 1 is 1. 4 times 3 is 12. So there's that 1/12 that I got from the model as well. They match. So again, we're still using this strategy, KFC, keep, flip, and change, whether you're starting out with a whole number or whether you're starting out with a fraction. And one important thing that I need the kids to be able to get down is drawing these models. So we'll practice a lot with the models. They want to jump straight to the algorithm because it's less work and it's easier, and they can just quickly divide or multiply. And that's going to get them in trouble whenever they are trying to read a word problem and they don't know whether it's adding, subtracting, multiplying, or dividing. So if they can get in the habit of drawing out the models of what this looks like, it'll help them lead. It'll help lead them to that answer and what operation to do. So please encourage them to practice when we are using the models. And if you see work coming home that says, that they were supposed to show the model and they've just got answers, I've already talked to them. But if you could do the same, that would be great because I really want them practicing that. All right, let me know if you have any questions. Thank you.